In today's lesson, we will be covering a topic that is covered by the Common Core Math Standard for 3rd grade Measurement and Data, point 8, which says solve real-world and mathematical problems involving perimeters of polygons, including finding the perimeter given the side length, finding an unknown side length, and exhibiting rectangles with the same perimeter in different areas or with the same area in different perimeters. In this lesson, we'll be talking about a set area with different perimeters. Now, here's our word problem. Miss Sandra is making a planter out of wood for her new flowers. She needs the area of the planter to be 18 square inches. What different length and width combinations of wood can Miss Sandra use to create her flower planter while still keeping the area at 18 square inches? Now, we know to find the area of a polygon, we need to multiply the width times the length of the polygon. So we already know that 18 square inches is the area, so that means we need to find the multiples of 18 to find out what different types of perimeters that Miss Sandra can have. So to find the multiples of 18, we'll just start with 1. Is there anything that we can multiply by 1 to get 18? How about 2 or 3 or 4 or 5? This is what we'll do, and we'll start with these numbers to see which of these first numbers might be a multiple of 18. We know that when a number is multiplied by 1, the number does not change. So this one is easy. 1 times 18 is 18. So yes, 1 is a multiple of 18. Now let's investigate with the number 2. What number can be added together twice to make 18? In other words, what is 1/2 of 18? Now we know that 18 divided by 2 is 9, and we know that multiplication is the opposite of division, right? So we know that 2 times 9 equals 18, just like 18 divided by 2 equals 9. So this means that 2 times 9 equals 18, so that means that both 2 and 9 are multiples of 18. Oh, how about 3? What number can be added 3 times to make 18? If you remember, multiplication is the same as repeated addition. So, if there is a number that can be added plus itself 3 times to make 18, this will be the same as multiplying that number by 3 to make 18, which would mean that it was a multiple of 18. Another way to think of it is to think of what number is 1/3 of 18. To find that out, of course, we would have to divide 18 by 3, so you could also say 18 divided by 3 is what number? Then you would know 3 times that number would be 18. What we want to know is if this is a whole number and can be considered a multiple of 18. Let's check. Here we can see that 6 plus 6, which is 12, plus 6 equals 18. So 3 6's, when you add them together, equal 18, which is the same as saying 3 times 6, right? Now, the next one asks, what number is 1/3 of 18? So let's check that out. 18 times 1/3 equals 18 over 3, right? So simplified, let's see what that is. Now, how do we simplify a fraction? That's right, we will divide the numerator by the denominator. So 18 divided by 3 equals what? That's correct, it equals 6. So, in the same way, we can also see that 6 goes into 18 3 times. So, now we can decipher that 3 times 6 equals 18, which means that 3 and 6 are also multiples of 18. Now you try, explore, and see if 4 and 5 are also multiples of 18. Use the methods that we just used to find out about 1, 2, and 3, and find out if there are any whole numbers that you can multiply by 4 and 5 that will give you the product of 18. Now that you've tried a few, you can see that there are no whole numbers that can be multiplied by 4 and 5. Now, if we think of multiplying 6, the next number in the sequence, we already know that 3 times 6 equals 18, and 6 times 3 is going to give us the same product because multiplication, order doesn't matter. So now we know that we have all of the multiples of 18 because we're back to 6 times 3. I also kind of like to do it this way. Here you can see 1 times 18, 2 times 9, 3 times 6. Here, 4 times nothing will equal 18, and there's nothing we can multiply times 5 to equal 18, so here we have all of our multiples of 18. Now let's take a look what these would look like in an illustration. Here's what a planter would look like that was 1 inch by 18 inches, or 1 unit times 18 units. Obviously this wouldn't be very practical to use as a planter, so Miss Sandra might not want to use that. Here we can see a planter that is 2 inches by 9 inches. And as you can tell, now there's still 18 square inches because we used multiples of 18. Here we have a 3 inch by 6 inch planter. The width is 3, the length is 6, and there's still 18 square inches in the area. Let's take a look at what this would look like with some physical modeling. Okay, so here we have 18 1 square inch tiles that are going to represent Miss Sandra's flower garden, or her flower planter. So the dimensions that we're doing now is 1 inch by 18 inches to make 18 square inches. Remember, we're doing this because 1 times 18 is 18, so it's 18 square inches. Alright, so see there's 1 unit here and 18 along the length, so that makes 18 square inches for this flower box. Miss Sandra probably wouldn't use this, it's not very practical, so she might try 2 times 9, for 2 being the width and 9 being the length of the flower box. To do this, we can just slide these over here, and here we have a flower box that would be 2 inches times 9 inches in the length. And as you'll notice, we still have 18 square inches total. Alright, so the next one that we're going to do is going to be 3 times 6, because we know that 3 multiplied by 6 equals 18. So a width of 3 times a length of 6 will give us an area of 18 square inches. To do this, all we need to do is move these down here to make our width 3 and our length 9, as you can see. Right here, there's the 3, there's the 9. So this would be Miss Sandra's third option for a flower bed, or flower planter. And these are just a few of the ways that you can demonstrate using physical modeling to understand how Miss Sandra could come up with different types of dimensions for her polygon for her garden planter.